All right, so I think this is recording. Let's take a look at solving these two quadratic inequalities. We're going to jump in here in number 5 and write this in standard form. Ignore the inequality and just set it equal to 0 for a moment. So now I need to factor this if it can be factored. If it can't, then I can always use completing the square of the quadratic formula to solve it. But I believe that we can factor this. Let's use the x method and write the middle term at the bottom of the x. Take the first term times the last term and put that at the top of the x. And now two numbers that when multiplied together give us the top of the x, but when added give us the bottom. And I think that 6x and negative 1x do the trick there. Let's put this information in the form of a table. Along one diagonal in our table, we put the first term and the last term, and along the other diagonal, we put the information that we found from our x. So let's factor both vertically and horizontally here. And I think that 1x times 3x will give us 3x squared. 1x times a negative 1 will give us negative 1x. 2 times 3x will give us 6x. Positive 2 times a negative 1 will give us negative 2. So we can come over here and say that this factors in the x plus 2 times 3x minus 1. And now it's easy for us to see the solution. Without writing it in factored form, it's kind of difficult for somebody to just look at this quadratic equation and instantly see that negative 2 and that positive 1/3 are the solutions. Let's put this on a number line. Negative 2 and positive 1/3. Positive values are to the right of negative values. Now, I'm trying to determine my solution set to this original inequality, and these are my critical points, or sometimes called boundary points. And I need to make a decision of whether to include or exclude those points from my solution set. And the deciding factor on that is to look at the original inequality, and we see that it's less than or equal to 0. When it's underlined like that, we're going to include these critical points in our solution set. So now the next thing to determine is to whether to shade in between those two numbers or to shade away from the middle and shade in the two tail areas. We look at the graph of 3x squared plus 5x minus 2 as one way to determine that. Since 3 is positive, this is a graph that would open upward. So what we have just found as far as this parabola is concerned are the two x-intercepts. Now, what part of the parabola are we interested in? We're interested in the points that are below the x-axis because it says less than or equal to 0. The values on the parabola that are below the x-axis all have x-coordinates that are in the middle here, between these two values. So that's how we're going to write our solution set, is from negative 2 to positive 1/3, and we're going to include both of those endpoints. So here's our solution set. There's our answer for problem number 5. Now let's go and take a look at problem number 6. It's a little bit easier to factor this one because the leading coefficient is 1. You can still do your x method if you like it and you like that pattern and stuff, but like I say, with the leading coefficient of 1, you know that this is x times x, which gives you x squared, and the two values that multiply together to give us a negative 8 but add to give us a positive 2 are positive 4 and negative 2 there. So this gives me x-intercepts of negative 4 and positive 2. So those are my two critical points, my boundary points, if you want to call them that. And the first decision I need to make is whether to include or exclude those from my solution set. And since this time it's a strict inequality, it says strictly greater than 0, I'm going to exclude them. I'm going to leave these as hollow points here, as hollow dots, and they will not be in my solution set. So now I need to make a decision of whether I'm going to shade in the middle or out in the tail area. The x squared plus 2x minus 6 is the graph of a parabola that opens upward because the leading coefficient is 1, and that's positive, so it opens upward. And what we have just found are the x-intercepts for that parabola. -4 and +2 are the x-intercepts. Now, what part of the parabola are we interested in? We're interested in the part of the parabola that is positive, that is greater than 0, and that's all of these points that are above the x-axis, and the values of x that will make those y-coordinates positive are values that are either strictly less than -4 or strictly greater than +2. Because any number that you pick in the shaded region, guaranteed that when you plug it into the equation there, you're going to get a positive value. When you have a separation like this, you're in this interval or you're in the other interval, and the mathematical symbol for or, we call it a union, and it looks like a big capital U. So you can easily see that why 0 is not shaded, because if you let x be 0, -8 is not greater than 0. So it's easy to see that that's why. See, last time it was easy to see why 0 was in the shaded solution, because -2, when x is 0, -2 is less than or equal to 0. So here's our solution set for number 6. All right, so I hope that helps, and I will talk to you later. Bye.